Good evening, everybody, and welcome to Kaplan. And tonight's little seminar that we're doing for you as adult educators for the who are focusing on helping students get their GED equivalency. We're just delighted to have you here this evening as we talk through what our new GED Live program is, which is a partnership with GED Testing Service and Kaplan Test Prep. So thank you all for joining us here this evening. My name is Arthur On. It's my pleasure to be with you here. I'm actually one of the instructors for our new Kaplan GED Live program. And during this session, we'll actually be having a little opportunity to talk through what we're providing for students who are looking to take the GED exams, and where your role might be in as educators, working, of course, with the many students that you do as well, regarding helping them successfully pass the GED exams. I've been with Kaplan Test Prep for about 13 years. I'm very passionate about the process of education. It's a really exciting thing for us here, especially at Kaplan Test Prep, to be able to work with students that frankly are just a little bit different demographic than we normally work with, but certainly exciting to see the possibilities of really helping to be part of that transformative experience for so many students, so many test takers in taking on the GED. I'm also joined here this evening, if you see in the chat on the right side of your screen, with Katie Sollenberger, who is actually the content manager for our program. So Katie is very well versed in all things GED tests, content related wise. She'll be answering any questions that you have during the session. So please use that chat that you see on the right side of your screen. Use that chat function there to just interact with us. We're giving you a little sample of what our GED Live program is. So please use that chat to ask me and ask Katie questions. We'll have polls. We try to keep things interactive in these our hour-long sessions here. So it's great, by the way, to see all of you here, all of you with the little geographical shout-outs. Always appreciate that, whether you're from Kentucky or Connecticut or Illinois or Hawaii or California or Michigan, wherever you are. I'm actually based in New York City. I actually born and raised in New York City. I feel like we're a bit of a rarity. If you ever grew up, the people who grow up in New York City tend not to stay very long, and of course, New York City being a city full of transplants, it just feels kind of awkward sometimes. But yes, I was born, raised, and now still residing in good old New York City. So with that in mind, let's get started with what we're going to look, which is kind of like the main point that we want to just cover today. And our concept here at GED Live, with the GED Live program, is to bring teachers together with students at a distance, because as you no doubt have experienced, right? Some of the factors that in you as instructors helping your students succeed, there are challenges, and one of the ways that we are best addressing those challenges is with this program of GED Live, which brings a personal touch to GED test preparation, with three main components. One, the live online classes. So we have these interactive online live classes that are available to all of our students, and it's unlimited basically. So when you sign up for the GED Live program, you're getting access to all of the classes, every class session that is available. Also, we have not only live online classes, but online teachers such as myself, and very interactive resources, content that is covered, that basically covers all aspects of the GED exams. And then lastly, we do have a support system for teachers, to supplement, your own curriculum with what we offer through GED Live, and help to have those opportunities where you may be able to engage with students that may be more challenging initially, right? Like, for instance, since who can't always get to class. I think we've all been there, right? We've all had at some point, like, yes, we're trying to meet with the student, and we know the student is motivated, but real life gets in the way, right? Like working a job, working in some cases 2 jobs, right? Where we see a lot of those challenges. Or maybe we see students that are studying and are really gung-ho about their studies, but they're just hitting certain content areas or certain areas in their studies where they may be struggling a little bit more than they might have anticipated. So GED Live can be a place where they can get additional independent work as well. We've seen that that is one of the ways to be most successful in all forms of test preparation, of just making sure that you're seeing more and more opportunities to try questions on your own, utilizing the teaching techniques that you've learned either through GED Live or, of course, through the programs that you're teaching as well. Okay. So our event today is basically to give you an opportunity to see what we call a blended learning model. And we're going to make this as interactive as we can. So I will actually, and this comes up on the next slide, but I'll just give you a little bit of a spoiler. I will basically be teaching content as we would in our GED Live program. So we'll be doing that blended learning model here tonight. We'll just also just mention that GED Live offers class sessions in all of the GED tests. The math test, the RLA test, the science test, the social studies test. Tonight we'll basically be doing some content, particularly from the GED mathematical reasoning exam. But again, we do offer content across all of the different GED tests. And also, during each of the two different segments, we will ask you to weigh in on some poll questions about our material and just some general questions about like how some of the impressions that you're getting from the students as you're working with students who are taking the GED exams. Our goal basically though for tonight, the biggest goal really is those last two that second last bullet point. Learn how you might use this type of content with your class in person, or again as an additional learning opportunity. Again, please feel free to continue posting those questions on the right side of your screen there. All right. So with that, again, what we'll be doing today, I'll be teaching as if you are a class of GED students, and look for content that you may want to reuse with your students. So even though this is obviously going to be a very small sampling of the content that we provide through GED Live, please be on the lookout. Please feel free to look for content you may want to repurpose somehow with your students. We can make this a downloadable file for you to share in class. So again, to that question earlier mentioned, can we access this PowerPoint online? We'll do even one better. We'll give you a downloadable file so that, again, you can share content. And one other thing that we noticed is this is actually our second time that we're running this event. The last time that we did this event, we learned that about 50% of you are teaching all of the subjects. And kudos to all of you, because in an ideal world, maybe a typical GED student would be meeting with 4 different specialists. But of course, sometimes just the way that the study patterns and study time happens, it's kind of difficult, right? So we know that there's a big onus on you as instructors to know all of the content. So as we've learned that the majority of you are teaching all of the different subjects, math may not be your most familiar subject. So that's one of the things that we're going to be, again, that's one of the things that we actually intentionally chose for this particular seminar to cover some of the math content here. Okay. All right, so with that, let's take a look at a couple things that we focus on here at GED Live. So we're going to give you a little sneak peek at 2 particular lessons that we teach. The first lesson deals with geometry and data analysis questions. We'll particularly be focusing on a couple of geometry concepts. And then the second part, we'll be looking at some more advanced math concepts as well. So let's start off with a quick review on one particular geometry topic dealing with triangles. So again, please interact with us. Let's have some fun. Let's give me the responses that sometimes that you would anticipate from some of your GED students as we go through some of this content. I would love to sort of make this a lively interactive class. So with that, first thing we're gonna look at is triangles, everybody. A triangle, remember, is a geometric figure that has 3 sides, 3 angles, and 3 vertices, or the less technical term would be 3 corners of a triangle. Triangles can be classified by either side lengths or angle measurements. So there are 2 different ways that triangles can be classified. One of those, listed here, is by the side lengths. So in that first triangle class, what do you notice? And go ahead and type this in the chat. Let's have a little bit of fun here. What do you notice about that, for even if you were not sure of the term, what equilateral even refers to? What do you notice about the ways that that first triangle are being marked off here? Like, what do you notice is kind of unique or kind of different about, or kind of very specific actually about this particular triangle, rather than kind of just drawing any old random boring triangle. And yeah, all of the angles are the same and all the sides are equal. So here we're going to focus a little bit on, in particular, sides are. All sides are the same. Equilateral triangle means all sides are the same. And also, as a side note, all angles are the same because class, again, oh gosh, I love this. Class, what do you know about the three angles in a triangle? What do the three angles in a triangle always, always, always have to add up? Have to add up to. If you have three angles in a triangle, right? Because a triangle is defined by three angles. What do you know about those three particular angles? Again, because they're equal, because a triangle always adds up to 180 degrees. Oh gosh, I love the exclamation points. I really appreciate that. 180 degrees. So of course, since you have three angles and they're all the same, 60, 60, 60. So that's an equilateral triangle. But now let's take a look at that second example real quick. What do you notice that's a little bit different in terms of the side lengths about that second triangle there? What do you notice is a little bit different compared to the equilateral triangle? That middle triangle. Again, don't worry about the word isosceles, class, right? Because again, you're not tested on the fancy, you're not necessarily tested on the fancy terms for those. But it certainly looks like candy corn. All two sides, sorry, only two sides, rather. Only two sides are the same. So an isosceles triangle means two sides of the triangle are going to be the same. So the angles don't have to be the same. But again, notice how all three angles will add up to 180 degrees. It's just an isosceles triangle, two sides the same. And then you have the scalene triangle. The scalene triangle. And in the scalene triangle, if you notice, wait, a little bit of a hint here is that notice how this side is marked off with like one little tick mark, but here it's measured with two little tick marks, and here it's measured with three little tick marks. So to be clear, it does not mean that's 1, 2, and 3. It means that all three sides are different. There we go. Three different sides. And I know that isosceles triangle kind of makes you think pizza because it's like that perfect shape, that classic New York pizza slice, definitely. All right, so that's a quick review there regarding triangles and how they're classified by side length. Now take a quick look at angle measurements. So if you notice here, a right triangle, and what is sort of like the unique characteristic that you notice there in the right triangle? And I love that note, by the way. If it's okay, I may share that with some of my students as well. On the scale, our weight is rarely the same, so scale and scalee making that connection. I love that. Thank you so much for sharing that. That sounds like a best practice to me. It has a 90-degree angle. That right triangle literally means that little box there. I'll kind of highlight that. That little box there indicates you have a 90-degree angle. And in a right triangle, since one angle is 90 degrees and all three triangles are 180 degrees, you'll notice that right angle has to be the biggest because all the other two angles, right? The angles over here and over here, those have to add up to the remaining 90 degrees. But you can't really have a triangle if like one angle is 0, right? If it's 0, you don't have any way of like spreading out that triangle. So that's in a right triangle, the right angle is always going to be the largest. Great. Let's take a look at a couple more quick examples here. An acute triangle, or cute triangle. So in the acute triangle, what you notice here about the angles is what? What do you notice here? So the example kind of gives you a little bit of a hint here. But what do you notice about a acute triangle? What do you notice about the angles that are sub in acute triangle? And yes, I saw someone mentioned just a moment ago, all angles are less than 90 degrees. There we go. All angles are less than 90 degrees. So like again, like for instance, even that equilateral triangle that we saw here, this is also like equilateral, meaning by the side lengths, but it is technically an acute triangle as well because all angles are less than 90 degrees. So an acute triangle means all angles are less than 90 degrees. And then what do you notice about, I feel like this word in everyday use is such a negative word, right? So describing something or describing someone as obtuse, but really in the world of triangles, we're not quite so judgmental. There's just one definition, about a triangle that's classified as obtuse. One angle is larger than 90 degrees. All angles, right? And by the way, Danielle, I like that. All angles are cute in a cute triangle. They're little, they're like kind of like miniature little angles in some way. You can sort of use that as a little helpful hint of remembering the difference between an acute and an obtuse triangle. Awesome. All right, so with that in mind, one other thing, just to dig just a little bit deeper here about triangles. A right triangle has one right angle, and the specific relationship of the sides of a right triangle. You have these two sides here, listed as what referred to as the legs of the triangle. And then one way to simply describe it is like the two sides that kind of surround the right angle. That's basically the legs of the triangle. And then you have that very fancy term here of called the hypotenuse, which literally means the side that is across from the right angle. And since the right angle is the largest angle in the triangle, the side that's opposite that angle will also be the longest side. So therefore, the hypotenuse is the longest side of the triangle. So just a couple quick things to note there about the two legs and the hypotenuse. The hypotenuse will always be the longest. In fact, there's actually a very specific relationship about the sides of the triangle. And that equation, referred to in math as what's called the Pythagorean theorem. But the Pythagorean theorem is basically the relationship of the sides of a right triangle. So one thing I just want to just be very clear here. You can use the Pythagorean theorem for all right triangles. And you can use the Pythagorean theorem for only right triangles. What we've seen is that a lot of people kind of conflate the Pythagorean theorem with just like this kind of catch-all formula that deals with any triangle. But just to be very specific here, to use the Pythagorean theorem, you have to establish a right triangle. Okay? And that right triangle, that formula, the Pythagorean theorem, a squared plus b squared equals c squared. C is the length of the hypotenuse, the longest side. Whereas the other two variables here, in this case we see a, and here we see b. A and b are used to represent the legs of the right triangle, basically the other two sides of that triangle. All right, let's take, and again, this equation is known as the Pythagorean theorem. All right, so with that, let's take a look at an example of a little thinking exercise, helping us to kind of master how triangles will work on the GED mathematical reasoning test. Take a look at this first example here. One side of a right triangle is 3 meters, and the hypotenuse of the triangle is 6 meters. Find the length of the remaining side to the nearest 10th unit, and you will notice here, again, being true to form with GED test-like questions, here we're indicating you may use a calculator for something like this. Okay? So here they tell us one side of a right triangle is 3 meters. The hypotenuse is 6 meters. So go and type this in actually really quickly, just to be clear. What is this question asking you to find? I've highlighted the information. That is given. But tell me, what is the question actually asking for? What is this question actually asking you to find here? And this is where you're going. One of the legs, good, the remaining side. So here's the thing I just want us to be clear about. If we're looking for the remaining side, just again, this little thinking exercise here before we get into the formula itself. If we're looking for the remaining side of this triangle, is the remaining side going to be 6? Is it going to be bigger than 6? is it going to be smaller than 6? Look carefully at the information we've got here and just see if we can sort of make that illustration. And by the way, drawing the triangle absolutely would help. I imagine that. Not to break the fourth wall all of a sudden, but I imagine you as teachers would absolutely encourage that, right? To draw a quick diagram for this. But here we want to notice is that, yeah, we are already indicating the hypotenuse is 6, and the hypotenuse would be the longest side. So if you're looking for one of the other sides of the triangle, at the very least, you know that other side has to be less than 6. So if we were to draw this out, or at that information here, where we have one leg, we have in this right triangle, we have one leg is equal to 3, and this is equal to 6. Well, basically, we're looking for this, and can kind of call that just b as one of the variables there, and we have a there, and we have a squared plus 3 squared equals 6 squared, and then from here, we're going to square those numbers here, the 3 squared and the 6 squared. So I'll give us a squared plus 9, because 3 times 3 gives you 9, equals 6 squared, which is 36. And then from here, we would subtract 9 on both sides. So if a squared is equal to 27, now I want you to fill in the last step here. A squared is equal to 27. But we want to know what a is. We want to know the remaining side. What do we need to do to figure this part out? What do we need to do to figure out what a is equal to? If we know a squared is equal to 27. And I'm bringing this up because, again, even though we're looking at geometry, it's a good way to recall some of the other topics that that you may have already looked at in GED Live here. We need to find the square root. Again, this is sort of an arithmetic example here, right? But find the square root of 27. And again, you can use your calculator for that. Take the square root of 27, and we've got a is equal to 5.1965244. And even if all those decimals look kind of intimidating, what we notice here is the question's asking us for the nearest 10th unit. So unfortunately, some of those answers that you might have been thinking, maybe 5 is the correct answer. In this case, no, actually, 5 wouldn't be the correct answer. What would the correct answer? What would that correct answer actually be? Correct answer would be 5.2, because we're rounding the 5.19 to the nearest 10th, and that would be 5.2 meters. And by the way, this instruction is all live, like what you're watching right now. I promise you that I am not a robot. This is not a recording, so I can definitely see everyone's comments coming in. Through. So please, again, keep asking questions. Either myself or Katie or Jane will be able to answer your questions. All right. Okay, with that, let's take a look at our next topic area, which deals with another geometry area, which deals with circles and how we can kind of make sure that we know all the various topics that are dealing with circles. So first, the definition. A circle is a closed set of points that are all the same distance from a central point, or simply the center of that circle. So in this diagram here, we've indicated that A here is our center. And basically, the circle itself is represented by all the points that are the same distance. So basically, if you drew in every single straight line from the center, like basically this point and this point and this point and this point, if you connected all these points, that actually makes the circle. You see that sort of just that part. But basically, you can see how it'll kind of go all the way around the center. So that's what a circle is, basically. All the points that are the same distance from one particular point there. Okay. Now, a couple of other quick definitions to note there, and I noticed the comment that came in a little bit earlier. Radius is half of the diameter. Absolutely. Like if you think about diameter, like again, this is something that you've probably breaking the fourth wall a little bit. You've probably noticed that students can kind of struggle with these terms. Think of it this way: like the diameter. Why is the radius half of the diameter? Well, the diameter is made up of one radius and another radius. So basically two radii, right? There are two radii together. That forms a diameter, essentially. So a radius is from the center to a point on the circle itself. The diameter is from one point of the circle passing through the center and then extending to the other end of the circle. That would be a diameter. And when two radii are combined, they essentially create a diameter. That's why there's that specific relationship there about diameter is equal to 2 times the radius. Okay, and with that, let's take a look. Let's take a look at a couple other things here about circles. The perimeter of a circle is called its circumference, the distance around the circle itself. Very similar to a term that you might have heard on GED Live, or of course in your own GED studies, that circumference and perimeter are basically one and the same, but the specific term dealing with a circle would be the circumference. The area of the circle is still called area. There's no fancy word. There's no special word for the area of a circle. It's still just called the area, essentially. And you have your formulas to remember. And by the way, these formulas were given in your as you're taking your GED mathematical reasoning exam. Circumference is equal to pi times the diameter. And again, another way of saying diameter is double of the radius. So you notice that these are basically two kind of formats to find the circumference. If you know the diameter, just use the diameter. If you know the radius, double the radius, and then multiply that by pi. So that's how we look at circumference. And then for area, the space inside of the circle. That space is pi times the radius squared. So whatever the radius is, square that number, and then multiply that by pi. If you're given the diameter, it's important to remember that relationship. Diameter is equal to 2 times the radius. So if you're given the diameter and you needed the radius, it would be half of that, basically. Okay. All right. And by the way, great questions coming in again. Thank you, Jane, for handling all those wonderful questions that come in. Glad to see so many people at least curious about our program here that we have. So let's take a look at one example of a question dealing with circles. So let's find the circumference and the area of the circle and round your answer to the nearest tenth. So again, we have an opportunity here to sort of think critically here about the information that we're given. So if we need to find the circumference, and here's what I'm going to ask you guys, please put it into the chat that you see on the right side of your screen. Don't be shy, just in case you might be a little nervous about which formula is which. But first, tell me, what is the formula for circumference of the circle, the distance around the circle? The distance around the circle here. And again, if that formula is basically going to be circumference is using what here? Well, they're using diameter, right? One of the versions of that formula uses diameter. But here, if you notice, are we given a diameter? That's where you just want to be careful here, right? Like just remembering to use the right version of the formula. In this case, circumference, another way of looking at circumference is pi times 2r. If we double the radius, there we go, guessed 5488, pi times 2r in that case, right? So we're going to double the radius, and then we're going to multiply that by pi. And then 8 pi, if we approximate that, remember it's going to be about 3.14. So that's going to give us an answer of, round that to the nearest tenth, of 25.12. Now for area, notice area is actually very specific about using radius. Again, since we have the radius here, just type this into chat real quick. What number are we multiplying pi by in order to get the area? Are we multiplying the 4? Because like the 4 is the thing that you see on the screen, right? The 4 is the thing that you're actually seeing right now. That you're like, oh, 4 and the pi, right? But this is where we want to remember that formula, of course, that the area of the circle is not just pi times the radius, it's pi times the radius squared. So 4 squared would give you the 16. Oh, by the way, thank you for noticing that. Again, rounding to the near tenth there. So the circumference would be 25.1. And for area, it's going to be 16 times 3.14. 16 times 3.14 will give us 50.24. And 50.24 rounded to the nearest tenth would be, of course, 50.2 square meters. All right. Great job here, folks, about going through circles as well. So with that in mind, before we go on into the second half of this, just wanted to point out just again a couple of the use cases. And I think these actually will help answer some of the questions I think that you wonderful folks have been bringing up into the chat. Again, thank you for interacting with us. But some of the typical use cases, and you can let us know actually you guys should let us know in the chat if you find any of these particular use cases might actually resonate with your group a little bit more, or a little bit more specifically for the needs and the needs of the students that you work with. So one thing that we see GED Live can be very helpful for is in-class viewing. So as you're running your own classes, you may want to use some of the GED Live interactive videos. So for instance, not just the live class sessions that we have here, but also we do have recorded versions of basically every class session for every class session that is given. So we do have a recorded version of that. So you can certainly use the recordings if you're running a class that might be not that might be outside the typical times that we're running our actual live classes. You can certainly use GED Live for homework assignments. Just have students like just simply use the supplement, the videos or the live sessions as supplements. Basically, be very direct and say, like, we want you to make sure that you're succeeding about the coordinate plane, or whatever it might be. So we can certainly use this as homework assignments. You can also use this as a distance learning option for folks that are unable for those who are unable to attend in person. There's also just the idea of the flipped classroom, right? Rather than kind of like the way that I think when a lot of folks throughout their whatever the span of their educational lives might be, it's like, here's work and then here's homework. But actually, there's the case of making the flipped classroom where you're saying, okay, watch this first as a preview, and then from here, after that, come to the class and bring your questions. Bring your questions about the particular topic that you saw. And we've seen a lot of those use cases where it's like, where it actually makes the class time seem more personalized, because that way the teacher, the instructor, such as myself or such as any of you, would actually be able to say, well, I already know what my students have seen. I already know what my students have have watched or have been practicing on their own first before we get into class. It actually can sometimes make the class sessions actually a little bit, just give it a little bit more of a personalized feel. And lastly, certainly one of the great use cases for GED Live would be for instructors to basically just do a quick little review for yourselves. Again, the burden on GED instructors can be quite onerous, right? Because you're knowing, you're a subject matter expert across all these different categories, right? All the different tests on the GED exam. So we can certainly use that. I've used that for myself to kind of know what do I need to teach? What am I teaching tonight? What is it that I want my students to walk away from in tonight's session? Oh, well, I can certainly use the videos to watch other teachers. At Kaplan, we have this sort of very close-knit family, tight-knit community of instructors, and we definitely are sharing best practices about the most effective ways to teach particular content. So with that in mind, glad to see again so much specific, so many questions here that you folks have. Let's take a look though again, just to continue on in our little sampling of what GED Live is. Let's take a look at a couple of categories dealing with advanced math. So let's take a look at one topic area deals with systems of equations. The solution to a system of equations is when the two lines intersect. So when you have two equations and you're trying to find the answer to the two equations, then it can be then basically the way to find the answer for those two equations would be the point of intersection, because an equation basically means all the different ways that answer could be correct. As an example, we were to say something like x plus y is equal to 10, and then go ahead, give me another example. But keep it simple. But give me another example of an equation that you might have here, besides the one that I have here. So one example might be simply x plus y is equal to 10. And as you're typing that, I just want you to know something here, folks, that when you have x plus y is equal to 10, this actually does not give you a very specific answer for x and y, right? Like what x is actually changes based on what y is, and vice versa. So here, the challenge is we don't actually have a particular solution for this equation because whatever x is depends on y. But we've got another equation about to go with that. X minus y is equal to 2. This is our system of equations. And essentially, the solution to this system of equations would be what is the point where these two equations combine. And by the way, 2x plus 4y is equal to 30 would be another great example. Another great example of an equation where we just can combine to find what those points of the point of intersection would be. So if two equations though have no solution at all, well, what does that mean about those two equations? If you're to draw them on a coordinate plane, go ahead and type that in, please. What would you notice about the two lines that represent the two equations if you're given that the two equations have no solution? Well, if you draw them out, what you'll notice, well, if there's no solution, then that means there's no point of intersection. So if there is no point of intersection between these two, well, then you have two lines that are going to be parallel to each other. They never intersect. They have no point of intersection. They have no solution. But if two equations have one solution, well, they'll have one point of intersection. Oh, by the way, great comment, Adrian. Thank you for mentioning that. Oh, I should throw that word in there on the bottom as well. You have two parallel lines when you have two equations with no solution. Now, if you have two equations that have one solution, well, you have a point of intersection. That point of intersection would be right there, and from here again, 1 point. And then lastly, if you have two equations that have infinitely many solutions, go ahead and type that into the chat. How would two equations that together have infinite solutions, how would they appear on a coordinate plane? How would they interact? How would they interact on the coordinate plane if you had two lines that had infinitely many solutions? Well, if there are infinite many solutions, that means that all of the points on both lines intersect. So if you kind of picture it, the two lines are coincidental. They're the same line. Adrian, thank you for phrasing it spot on there, right? They're basically almost like one line literally like right on top of the other, or essentially one line. One line that's like visually it just kind of looks like one line. So there we go. Infinitely many solutions. Sorry, infinitely many solutions means you have one line, essentially, or one line on top of the other might be another way of phrasing that. Okay. All right. Let's take a look then at another example here of graphing. So when you're solving a system of equations, solving it graphically, you want to notice that the two components for here. Like for instance, our first line here, y is equal to 2x minus 4. If we're plotting this line here, we can take different points that would work here. So if you can set up like a quick t-chart, might be a quick way to graph that. And there are other ways, of course, that we can graph lines, but for the purpose of this exercise, just want to point out here the point of intersection here. X and y, for instance, if x was equal to 0, 2 times 0, 0 minus 4, that will give you negative 4. So plug in one number for x and then see what the result is for y. So 0 comma negative 4. We can plot that. We can plot another point, 4 comma 4. 2 times 4 is 8. 8 minus 4 is 4. So another point would be 4 comma 4. And then we can essentially, so if we have that, we can essentially draw the line between those two particular points. Now, if we have the other liner, x plus 2y is equal to 7, again, find points for x and y. So for instance, if you plug in x is equal to negative 1 plus 2 times 4, which is equal to 8, that will give you plus 7. So 1 point would be over here, and another point, 5 comma 1, would be over here. And then you may be able to notice, oh, there's my point of intersection here, 3 comma 2. So that would be your point of intersection for these two lines, 3 comma 2. So 3 comma 2 would be the answer that would work for both equations. All right, and with that, let's take a look at another way to solve. And I think I saw, someone mentioned before about using a little bit more of an algebraic technique, right? I think Lakeisha, you did that, right? Substitution or elimination. And yeah, if you're not using the graphing technique, if you're using the algebraic technique, and sometimes a GED mathematical reasoning exam question will kind of necessitate using algebra over graphing, or sometimes vice versa. But if you see this system of equations here, x plus y is equal to 9, and 2x minus 3y is equal to 8, and 2x minus 3y is equal to 8, solving this algebraically, there are those two techniques that we can use here. Step 1, get x by itself in either equation. But let me ask you folks this, between the first equation and the second equation, which equation is going to be a little bit easier to get x by itself? If we're looking at equation 1 and equation 2, which of those two equations is going to be a little bit easier to get x by itself? And there's probably one thing that you're noticing here about the x's and the y's for equation 1 and equation 2. Equation 1 just has x and y, whereas equation 2 has 2x and negative 3y, and we want to get x by itself. So it's probably a little bit easier to work with equation 1. Take the x plus y is equal to 9, and move the y over to the other side by subtracting y on both sides. And so now you have x is equal to negative y plus 9, and then you'd basically move this over here. And you can, so that would be one way to essentially solve that. The other way, the second step rather, substitute that into the other equation. So we're now, instead of this 2x, well, we know another way of saying x. X is negative y plus 9. We can substitute that in. And then from here, we want to remember our distributive property, multiplying the thing on the outside by everything inside the parentheses. So that'll give us the negative 2y plus 18 minus 3y is equal to 8. And as you're going through all of these different steps here, go ahead and tell me, what do you get for y? To solving this equation for y, what will you get for this? I'll give you a few moments to just do the quick math here, and then go ahead and type it into the chat. So you have the negative 2y and the negative 3y. We have our common terms there. Negative 2y plus negative 3y, that's negative 5y. Negative 5y plus 18 is equal to 8. And again, our goal here to get the y by itself is to subtract both sides by 18. That gives negative 5y is equal to negative 10, and then of course y is equal to positive 2. Now that's what y is equal to, positive 2. And then from here, if we wanted to know what x is, and if you notice what step 3 says, and step 3 says substitute y into either equation to solve for x. Either equation to solve for x. So, but let's be realistic, folks. Do we want to substitute y equals 2 into this equation or this equation? Equation 1 or equation 2? This is going to be like the eye checkup, when you go to the optometrist. 1 or 2? 1 or 2? So it's which equation looks a little bit easier to work with? Equation 1 or equation 2 here? And yeah, it feels like equation 1 is going to work a lot simpler here. So we can substitute x plus 2 is equal to 9. And of course, x then would simply be equal to 7. There we go. So we've got our points that will work here for both of those. Okay, so x is equal to 7 and y is equal to 2. So those are the x and y's that will work for both of these equations. All right. So with that, we can take a look at the other technique to solve for a system of linear equations. This is using what's called combination, or often we hear a lot of people refer to as elimination Um, I don't know if I look younger than I really am. I went to high school many years ago, and I actually remember hearing the term combination a lot more. But I know that generally speaking, elimination is a term that's often used to describe basically the same technique, because the idea is that we're going to combine the equations together so that we can eliminate a variable. That's essentially where we're getting these terms from. So if we have these two equations here, first step, make the coefficients of one variable equal. So if you notice here, if we just kind of smush these two equations together, right, x plus y and 2x minus 3y, we're not able to get rid of a variable. So if we make the coefficients equal, for instance, if we take that first equation and we multiply that first equation, x plus y equals 9, that we've written over here, and we multiply that by 2, that'll give us 2x plus 2y is equal to 18. And now we have the 2x minus 3y is equal to 8. Remember, that was our second equation. Go ahead and type this in. When we combine these equations, first just tell me this. What are we doing with these two equations? Our note here says that we add or subtract the equations to eliminate the one variable. Just want to be clear here. What are we going to need to do with these two equations to eliminate one of those variables? What is it that we're going to be doing with these two particular equations to eliminate? Again, using that elimination strategy here. And what we're going to do is, well, we have 2x and we have 2x. So the way to get rid of the x terms here is to subtract those two equations. And here's where we want to be careful. Notice, we're not just subtracting 2x. We're subtracting the entirety of that second equation. So subtracting the second one from the first one. Okay. All right, and so with that, when we subtract, notice the one little tricky thing, just the one thing you want to be careful of. With the x terms, great. The x terms go away. Wonderful, right? It makes our lives a lot easier. However, notice we have the 2y, and we're subtracting negative 3y. Go ahead and type that in. When you have 2y minus negative 3y, what's the thing that you're actually doing? And it's kind of weird here, but you're actually having a negative and a negative, right? Like you're subtracting a negative. So when you subtract the negative, what are we doing with those terms? We're essentially just going to add those terms together. 2y plus 3y is equal to 5y. And then lastly, 18 minus the 8 is going to give us 10. And notice we'll get the same answer. 5y is equal to 10. Y is equal to 2. And then again, step 3, substitute back into either of those two equations. And thank you for humoring me before. I won't ask you to do it again. We're clearly going to substitute into that first equation, right? When y is equal to 2, yeah, let's make our lives easier. Let's find out what x is. X plus 2 is equal to 9, and x equals 7. And again, notice we get the exact same answer, 7, 2. So both of these are perfectly acceptable algebraic ways of finding the solution for two equations. You can also use the graphic approach, where if you can make a quick sketch of the two lines, and the point of intersection would represent the solution of those equations. All right, and with that, let's take a look then. Let's take a look at one example here. A little more opportunity for interactivity. We just want to make sure you. So one of the things that certainly you as instructors, I think, will find very valuable when if you're participating in these lessons just for the purposes of your own professional development, would be like, as we go through these lessons together, what we often do is bring up polls where our students are able to click on the answer that they got. And what I will say, and again, I'm breaking the fourth wall here, but one of the best things about this feature is really that it gives us real-time analysis on how our group of students is doing. So for instance, I know as an instructor, if I'm teaching this particular question and I've seen that like 96% have gotten this question correct, great. I feel confident about the topic itself. and I can be more efficient as an instructor to target other areas of content that a student might need. But if I'm teaching this question and I know it's only like 40% of the group got this question right, what that tells me as an instructor is we want to make sure that we're maybe going through a little bit more thoroughly or a little bit more in detail about the ins and outs of the particular question. So that's one great feature that we have here in our GED Live classes. So go ahead and use that. You can scroll down a little bit and you'll see the poll. And I'll just simply ask you A, B, C, or D. Put down the answer that you have for this one. So you don't have to put down a blind answer, of course. As you're trying the question on your own, go ahead and click on the answer that you believe to be correct for this. So let's take a look at this one here. Where does the line with the equation x minus 2y equals 4 intersect with the line with the equation of 6y plus 5x is equal to 4? So we're looking for the point of intersection, a point of intersection with these two lines. So we have, again, our two equations that are set up here. And again, a lot of people will kind of naturally gravitate towards elimination. Some people will naturally gravitate towards substitution. Some people may even naturally gravitate towards making that T-chart and then drawing out points and seeing which of those points lists out where the point of intersection would be. So in this case, we can use substitution here by moving the negative 2y over to the other side. We have x is equal to 2y plus 4. And then, of course, once we know what x is, once we have isolated one of those variables, then we can substitute that into the other equation. 6y plus 5 parentheses 2y plus 4 is equal to 4. And then when we multiply those terms out together, go ahead and if you haven't put your answer into the poll, that's okay. But go ahead and just type this actually into the chat. Just give me the result that you get for y. Before you go any further, just give me the result that you get for y. We're going to combine the like terms. 6y plus 10y. So we have 16y. And then we're going to move that 20 over to the other side. So if we subtract 20, if we subtract 20 on both sides, we get 16y is equal to negative 16. And when we divide both sides by 16, y is equal to negative 1. Now, here's a way, though, to just really instruct your students on the important parts of being able to analyze information, to be able to critically think here. If y is equal to negative 1, well, the way this question has been set up, if you look at the choices, tell me what you notice about the answer choices. Remember, we've only solved for y at this point, right? We know that y is equal to negative 1. And the algebraic approach here would be to substitute the value of negative 1 into one of those two equations there, either the first equation or the second equation. So if y is equal to negative 1, yeah, wait a minute. If you look at those four choices, there's only one answer choice that has negative 1. So therefore, this is actually a good opportunity to encourage some saving of time here. Choice A would be the correct answer. Because yes, exactly, A is the only one with negative 1 for y. Awesome. All right, so with that, we've gotten a little bit of a sneak peek here in terms of like what our GED Live program is. GED Live program is, again, you can interact with us in the chat there with Katie. By the way, Katie is also one of our GED Live instructors. She works in addition to being our content and curriculum guru for our GED Live program. She's done just an amazing job. Also as an instructor, and she's one of Kaplan Test Prep's finest instructors, I will say. So please continue to post any specific content areas or content-based questions that you might have. But just to kind of put a little bow on what we've looked at here, today, and just a couple of things we just want to make sure that you head out here. Just a couple quick takeaways here. So this is certainly not going to be the last time that we want to speak to folks here that are folks such as yourselves who are part of this community of people who are just really impressed me about just the work that you do to help people get their high school equivalency. by passing the GED exams. So we will be running additional events in our GED Educators series. And we're thinking right now about a quarterly basis, and we'll have some of these topics that are listed here about, for instance, test day tips, like what are the specific things outside of just simply memorizing formulas or memorizing content, because even for folks who memorize like all the important historical facts to do well on the social studies test or the scientific reasoning or scientific method to help with questions on the GED science test. It's more than just that. We've seen that from our students. So wherever that we can give our students more opportunities to really be able to go into the test room with confidence. So test day tips, managing test anxiety, positive studying habits. As you all no doubt know, that you're working with students who find it probably difficult just to find the time to study or to be most efficient on how to study. So we will be running some additional events in the GED Educator series, and some of these topics will come up, and we'll probably have a few other topics queued up as well. We are developing a pricing model for your program so that you can purchase comprehensive content based on the feedback from these sessions. And please, again, provide us with whatever additional feedback that you can. Katie has put that link there in the chat there, so please do fill out our post-event survey. Leave us additional feedback there. And again, thank you again for coming. We'll stick around here for just another minute or so. We certainly appreciate your time that you've spent here this evening with us here at Kaplan Test Prep and the GED Testing Service. And we want to wish you all many thanks for coming here tonight. And please do stay tuned to additional opportunities that we'll be having in our Educator Series. And please continue to ask Katie and Jane any questions that you might have regarding our program, regarding our content, the amount of content that you have here. And thank you again, for your participation. Thank you again for your participation with tonight's event. So thank you all very much. Have a wonderful rest of your night. Bye-bye.